On today's episode, we don't go to space, we go down to the core.
Yeah, NASA accidentally built the SLS upside down, and now we're going to the core, I guess.
Yep. I'm Paul, the pressure-fed Terranaut, and who are you?
I'm Face of Sarcasm, and I want to turn around and go home.
See, I was thinking you'd go with a joke title, like, I'm the face of silicon, or silica, you know?
No.
Oh.
The core!
The core. Yes, we're doing another movie special, and if you're wondering, wait, the core isn't about space? You're
the opposite
wrong.
of space.
You're wrong. There's a space shuttle in it. I've seen
Yeah.
GIFs of the shuttle landing on the site formerly known as Twitter, which now has a name that gets you banned in schools. It's got an X in there, that's why.
Oh, okay. That gets you banned in schools?
Because it's got an X. Yeah, Mr. Healy talked about this once in chemistry, where he did like the different electron shells and the shapes of them, and they were X's. So at one point, the guy who programmed the website had XXX, which is what they also used for adult websites.
Oh.
And that's what, so
Oof.
that's why people are making fun of Elon's decision to call it that. So,
Yeah.
so
Makes sense.
The Core is a movie that is 21 years old, so it can drink.
Nice.
It's a notorious sci-fi disaster film where a team of scientists drill to the center of the Earth in a ship made of Unobtanium, which is spelled either with an I between the A and the N or not. I do it both ways, country and western.
Is it like the aluminum, where it's like aluminium?
So the British version is Unobtanium with the I. I don't know. And to do this, they're doing this to set off nuclear weapons to restart the Earth's core because somehow it stopped spinning.
How do you stop a Mars-sized core from spinning?
Well, with 6 nuclear weapons, apparently.
Just 6. Wow, that's a bargain.
So the core is notorious because of how wrong the science is,
Oh yeah.
as in almost all of it. You know what the most accurate part of this movie is, scientifically?
The fact that there are people in it? I don't know.
So the top layer of the Earth is called the crust.
Oh no.
Then there's the mantle. Then there's the outer core, which spins and makes the magnetic field. Then there's the inner core, which is a solid chunk of iron nickel.
Wow. Okay. Well.
Yes. But as a warning, we actually do like this movie, though.
This is a great movie. You should honestly check it out. It's fun.
Yeah,
It's a really fun movie.
Yeah. We saw it in the theaters when I was 7 and you were 5.
Yeah.
That may have had an influence on things.
I don't think so. I think we were doomed from the start.
That is true. Actually, that's what I say in my interviews, too. It's like, why'd you become an engineer? Well, I was doomed from the start. My dad was one. So, I do think this was instrumental in my shift towards wanting to become an engineer, though. Because, when you watch space movies, you know those work, because space is easy. It's empty, right? But could you actually go to the center of the Earth in a ship? The answer, of course, is no. But I dug into it.
Yeah. But what if you could?
What if you could? I also own the soundtrack to this film. This is actually my copy of the CD right here. I own this. I sometimes listen to it while driving to work. It's a fun soundtrack. It's probably one of Christopher Young's best. Okay, sorry for that, folks. Acrobat quit on us.
Thank you, Adobe.
Yep, thanks, guys. Maybe it's going to sell it to people now, the slides. So
of course.
people make their own AI-generated version of the podcast.
Uh-huh. Good luck.
So as I was saying, I own the soundtrack to this movie. I actually really like it a lot. It's probably one of Christopher Young's best. It's also, if you listen closely, very similar to the soundtrack to Swordfish, the one with John Travolta and Hugh Jackman. And Halle Berry. Oh, she's in that.
Yeah. Remember, 2002 to 2003.
Yeah.
Wild times.
Yeah. So The Core is actually based off a book, sort of, called Core by Paul Proust. That was written in 1993. So in that one, kind of the backstory for that one is, in that one, a Manhattan scientist engineer... No, Manhattan... Oh, goodness, I can't speak. It's an engineer or scientist at the Manhattan Project discovers a material that can cut diamond.
Ooh.
It's called Hutterite because the main character, not the main character, but his name is Cyrus Hutterite, discovers this. It's a super strong material, and he proposes using Hutterite to build a telescope into the Earth, basically a giant drill to drill to the center of the Earth.
Okay.
The problem is you can't really make Hutterite. It's a byproduct of the Trinity test.
Yeah. Well, you just use a lot of nukes. Like, come on, it's easy.
Yeah. I'll talk about this later, but it's an actual proposal. So he can't make Hutterite, but he keeps making all these proposals, but he vanishes in the mid-'80s. And his son, Leiden, which is a really weird name, holds the patents and all this. And at the beginning of the book, someone actually figures out how to make Hutterite relatively easily, and they start building this telescope into the Earth.
Ooh, okay.
But they find that someone else has been digging. Cyrus was taken for a job by, Palestinian support rebel groups to drill 400 miles into the crust and into the mantle to place a nuclear bomb in a deep fault line to destroy Tel Aviv in an earthquake, but not have anyone recognize it.
That seems like a very difficult way of doing that.
It is. But, you gotta do what you gotta do, I guess. I don't know.
Yeah.
But they do reach the center of the Earth with the telescope, the drill in Core City in West Texas, and they do find the site because it generates earthquakes. Because you gotta remember, all that rock is under a lot of pressure, so it generates earthquakes.
Yeah, it's gonna start slamming into itself, rubbing against itself. Yeah.
So there actually is a spot in the book where Cyrus goes down into the hole they've dug to stop the nuke, and then Leiden follows in another one to go pick up his drill part thing. So.
He dropped his keys down there?
Yeah, he dropped his keys to go pick them up, yeah.
Yeah, okay.
And at the very end, there is a magnetic field issue with the Earth in the book that's talked about, but it's not prominent. And at the very end, a nuclear weapon is brought to the core of the Earth and detonated to modify the interior, now that we understand how it works.
Huh.
So you can kind of see where this movie came from.
Yeah, I could see some of the broad strokes. Fortunately, they did not keep any of that political stuff involved, because, oh boy.
Well, I mean, it is still kind of very 2003 with some political messaging. We'll get to that.
True.
I make note of it, don't worry.
Okay.
And so, as a general disclaimer, are you a geophysicist, geologist, or in any way related to the science of this film?
Oh, of course. No.
The closest I am is that I sometimes do research on materials. I did want to be a material scientist for a bit, because I was reading this book and went, could you actually make that? No. But, and then we're also going to talk about the space shuttle, because there's a space shuttle in this. I'm an aerospace engineer. We talk about the space shuttle. That's what we do.
Yeah. My knowledge of geology is that that's a rock. It's kind of brown. That's a rock.
No,
it's kind
that's
of
a
gray,
mineral.
And that's a rock that's kind of red.
It's a mineral.
Oh, yeah, it's minerals.
Gosh.
It's minerals.
All right.
It's mineral, Murray.
Exactly. So, beginning of the movie, very cool title sequence. I remember when I saw that in the theaters, and I thought it was the coolest thing ever. Because it's got the big Paramount Mountain, and you go close to it, and you go into the Earth. It's really cool.
Oh, yeah.
Yeah, cool. A whole bunch of people die in Boston because their pacemakers die, even though that wouldn't actually happen.
Yeah, it was a really cool, awesome, big shot, though, because it's just a giant tracking shot of, all of these different accidents happening at the same time.
You should watch it just to see how far movies have changed since 2003, and how they're made and just what's in them. So we'll just, again, error number one here is this wouldn't happen at all.
Yeah, in general, yeah.
Earth
the core is a little difficult to stop spinning.
Yeah. Actually, the inner core of the Earth is actually spinning a little bit slower than the rest of the planet.
Really?
Yeah.
How do you know that?
Seismic waves.
Okay.
Yeah. It was first discovered in about 2009.
Oh.
Yeah.
Interesting.
So this one, and even then, even without a magnetic field, it'd still take a while for it to decay. And there's been periods of Earth's life where we've had minimal magnetic field, right, during magnetic pole flips. There's a few
and that's when the mass catastrophes happened, right?
Yeah, the documentary film 2012 talked about this.
Ah,
so in real, that's what would happen, actually.
Right.
Yeah.
Super accurate.
Yeah, documentaries right there.
Mm-hmm. Yeah.
So this wouldn't actually really happen like that. The big concerns are microwave radiation. No. Solar wind damaging electronics, and then UV radiation giving everyone skin cancer. That's your real concern.
Gotta limit your time at the beach.
Yeah.
Basically.
Yeah. So we introduced our good main character, Dr. Josh Keyes, who somehow forgot that he has security clearance.
That's a thing to forget.
Yeah. He also has very 2003 hair.
Yeah.
Yeah. Then there's another disaster with, in Trafalgar, I think it is, Trafalgar Square, birds.
The birds, yeah.
The birds attack people, mayhem. We're not focusing on that.
I guess.
And yeah, Josh wants to build a model of the magnetic field of the Earth because he's figuring things out. Of course, he's talking about, oh my gosh, there's so much data we got to collect from the web.
The internet.
Yeah, we got to use the T1 line. My goodness.
Got to dial AOL. Like,
yeah,
man,
it's very 2003.
Yeah. I mean, the whole reason that he's looking into this is because the general brought him to look into all those people that had died, right? With Serge, that's where we introduced Serge.
Yeah, Serge
as well.
Yeah,
and then he sees the stuff that's happening in Trafalgar, and then
there's other stuff happening, and it's all interestingly really related to the magnetic field. Weird,
curious, huh?
Yes, and of course, there's a really cool shot where we see Endeavour, which we just recorded the first flight, which that episode's coming out after this one.
Yeah,
a shuttle named by children,
literal children.
Yep. Which this one's basically flown by Rebecca Childs, so it's a conspiracy.
It's a conspiracy, yeah.
Yeah.
They crashed the shuttle intentionally.
Yeah.
To cover up the fact that children named it or something.
The bees did it. The bees did
it. The bees. The bees are back.
Yeah. So in this part, which the shuttle's actually, I think, the correct orientation, roughly the right spot for deorbiting.
Nice.
Yeah.
Yeah, because that's Australia.
Yep. There's Australia, and it's coming in to land at Edwards. So, and I think it's doing an ISS mission because if I took my protractor to one of the images next to see if it would like what the angle was of the orbit. And it's like, it's 56 degrees. That's probably ISS.
Okay, yeah, it makes sense.
Yeah. But the problem is, after re-entry, the shuttle gets out of radio blackout. It gets in. It's off course. It's gonna hit LA.
Oh no!
Because the magnetic field.
The horrible tragedy of that.
Yeah, because the magnetic field definitely influences inertial guidance systems.
Mm-hmm. The thing where you subtract where you are from where you've been.
Pretty much. Yeah.
Yeah.
You don't really. You could have some electronic interference with it, but that's why you have 3 guidance computers on board.
Yeah.
That's actually why you have them.
To check each other's math.
Yeah. Now, of course, some errors might crop up. The Boeing 727 actually had an error in its voting system for avionics that wasn't caught until after it was out of production in the mid-90s.
Wow. So it really didn't matter.
Yeah, it's one of those things where it's on these certain conditions, under very odd certain conditions, that this would actually happen. It's a Tuesday, the pilot's favorite color is blue, and he's feeling kind of sad, whatever.
Yeah.
But the shuttle uses inertial guidance, which means that this wouldn't even happen. Also, the commander would not be floating around after the ohms burn. He'd be seated.
Yeah, incredibly inaccurate.
And the mission would have more than 3 people on it.
Yeah, because at this point they're trying to just pack as many people as they can in there, right?
It's on average about 5 crew on each shuttle mission.
Yeah, and they only have 3.
Yeah, so the last time they had 3 crew on the shuttle was never, actually. It was 2 and then 5.
Wow. Okay.
STS-135 had 4, but that was just because it was the last flight.
Interesting.
Yeah.
So it's never had 3 on it.
I don't think it's ever had 3, no.
Huh.
Yeah.
Weird.
So let's go. So here it is, re-entry.
You can see that it has like the sort of the stringy effects in re-entry, because that's the magnetism, the electromagnetism in the field.
Yeah. And so I looked. There is no shuttle mission patch that looks like this. It looks like a shuttle mission patch.
Yeah.
It's the closest one to it is STS-69.
Nice.
Yeah. Which I think Bruce Melnick, which you just did for STS-49, I think he's on that mission.
Oh, perfect.
Yeah, it's just weird. But this is not mission control, as you can tell.
Yeah, it looks way less interesting.
I think this is the leftover set from Deep Impact.
Okay.
I think it might be. It's nothing like the one from Armageddon, though.
Yeah, that's way cooler.
Yeah. Where am I? Oh, also, so Beck is supposed to be the youngest person in space. Mm-hmm. The youngest person in space was 25. It was German Titov.
And how old is Beck supposed to be?
We don't really know. The youngest woman to ever fly the shuttle, I think it was Janice Voss, I think it was, and she was 36.
Okay, so bit of an age gap there.
An age gap, so it's unclear how accurate that would be.
Okay.
So, and the shuttle would so it's gonna miss Edwards, which is
no, it wouldn't, right?
I did the math on this actually. So
Okay.
right there, it's about 180 miles from Edwards.
Mm-hmm.
It could do it.
It's got the cross range. How much range does the space shuttle have?
So I was doing some digging last night, and so Columbia, on its last flight in 2003, 2 months before this movie came out, would have come out at radio blackout at 16 minutes before landing over Louisiana.
Okay.
And it was going to land in Florida. You gotta kind of,
so that's a long range.
Yeah, so it's supposed to come about here and land there. 16 minutes. You'd have about 16-ish minutes to correct for this, assuming you'd have this error somehow.
Mm-hmm. That's a long time.
Yeah, so I think that'd be the procedure to land it, is just try to make it. And because, again, over here, it's just dry. It's dry lake bed, which the shuttle did do a dry lake bed landing once. In the 90s, I think.
Was it like a test or accidental?
I think it was because one of the hydraulic sensors was bad on one of the landing gears. So they thought, okay, well, we're not going to put it on the real landing pad, I guess.
Yeah, tarmac's a little rough on those panels.
It was something like that, but it did do a dry lake bed landing.
Okay.
So if it couldn't make it to Edwards, I don't know what the procedure would be because this has never happened. I couldn't find. It took me 2 weeks. I don't know.
Mm-hmm.
But
it could probably make it though, right?
Yeah, and even that, again, it's flat over there. You could try a dry lake bed landing. What you do is you would pretty much get everybody off the shuttle. You would abandon ship. Mm-hmm. If the pilot, if the commander was crazy, he'd maybe try to land it if he wanted to. But the procedure would be to actually, because you have the entrance door, blow that off, and there's a big long pole that extends out that you would slide off of and get out of the shuttle and parachute out.
You still have to parachute out, or?
Yeah.
Oh, wow. Okay.
Well, yeah, you're still at, altitude.
Oh, so you're still flying, like not even landing.
Yeah, you're still flying.
So just jump out
potentially.
When it's still. Wow. Okay.
That's one abort procedure. That's one thing you could do. Or like the extreme scenario, fly along the coastline and ditch it.
Yeah.
After you jump out, of course.
Okay. Yeah. So still either land at a dry lake, either make it to Edwards, land it at a dry lake bed, or dump it in the drink and jump out.
Yeah. So the shuttle actually could land at any runway that's about 10,000 feet long, so about 3 kilometers, theoretically.
So is LAX that long?
Yes.
So it could just land at LAX.
It could land at LAX. It'd be really hard to get it out, but I don't know.
But that's a future problem.
Yeah, it's somebody else's problem. Actually, there was a book, Shuttle Down, where a polar launch of the shuttle aborts and lands on Easter Island. And it's all about the logistics of getting the shuttle out of there. Because the 747 carrier aircraft could theoretically land on that airport there, but the shuttle is already parked at the end. So now what do you do? It's really interesting.
Just get out and push. Come on.
Yeah. So I don't know. It's dubious if this would be how well this would be, but it's not as cool.
So us outside nerds figured out 4 potential ways of landing the shuttle, and none of them involve crashing into LA.
Yeah, and you can see kind of where they are at altitude, what's going on, and again, you're talking about 15, 16 minutes to land.
Okay.
So it's not. You have some time to troubleshoot. Yes, the shuttle has the aerodynamic qualities of a brick. But it.
Yeah, it can still fly a decent amount.
It's got wings, and it's built in with cross-range capability. There's S-curves that the shuttle would do to bleed off energy.
Yeah.
So. Questionable.
Yeah. It wouldn't crash into LA.
Yeah.
That's the conclusion we've come up with.
Yeah, this whole situation probably won't happen.
Yeah.
So here it is, though, coming in over Dodger Stadium, which is a good shot,
Yeah.
Yeah, you guys gotta have spectacle in these movies.
Of course.
Yeah.
I mean, it's the space shuttle flying over L.A. Wow.
And it does a sonic boom, too, which the shuttle would do.
Yeah.
This thing is coming in
Yeah.
very fast.
I mean, it was just in orbit, a few minutes ago.
Yeah. So, Beck reroutes the shuttle to land in the L.A. River, which is a river in a very loose sense if you've ever seen it, apparently.
Yeah.
Yeah. Just like nothing there.
It's like a glorified, like, almost highway, right? It's just concrete.
Well, movies like to film in it, so I don't know.
Yeah.
So I don't know if that would be the smartest decision you would have for an abort contingency like that. I do think that you would probably just aim for an airport or aim for somewhere flat.
Yeah, and there's plenty of spots to do that, as we just discussed.
Yeah. So accuracy. Don't want to deploy the drag chute on the shuttle because snagging a bridge would be a very bad thing to do.
Mm-hmm.
Do some serious damage to the airframe.
Yeah.
And
rip the tail off, right?
exactly. And those are the actual gear controls. I looked it up. So
okay.
yeah, so if you're flying the shuttle, it'd be the bottom left
Bottom left.
of you. It wouldn't be like that deep down, right? Because it's like when you're driving your car, right?
Uh-huh.
So it's kind of like
So it's like the AC control almost, but it's the gears.
yeah, but it's on the left. Yeah,
It's on the left. Okay.
it's like where you adjust your lights.
Okay. Oh,
Yeah, it's,
all right.
it's somewhere around there, and this is what it actually looks like.
Dang. Look at that.
So whoever built that mock-up of the cabins, good.
Did a spot on job.
Yeah. Also, it's all publicly available information. I found this from a report from 1989, so you can find it.
So you think, yeah.
Yeah. But the biggest inaccuracy, though, is you can't retract the shuttle landing gear. It has to be
Yeah, I
manually
noticed in the
done.
actual diagram it only says up, but
Yes.
not down.
Exactly. So it would lose control after that landing, after you retract the landing gear somehow, or it broke, I guess.
Mm-hmm.
I don't know what it would do as an aircraft, because if you've seen plane crashes, once they hit the ground, they just kind of fall apart.
Yeah.
So I don't know.
They're built to fly, right? They're
Yeah.
not really built to go on ground.
And
they're
this
they're
thing
supposed
is-
to be light and not.
Yeah. And this thing is also built of tiles, so it'd just be dumping so many of them. Just leave so many trails. It probably. Again, this has never happened, thankfully, so we don't really know what it would do. So.
But it wouldn't be great. It would basically just be leaving a debris trail across
Yeah.
where it was slamming into the ground.
But but if you look, actually, I think it's here. We go. You see, they do lose the. It's the elevator in the back, because that snapped off the tail.
Yeah.
That fell off. So that's accurate.
Okay.
What else was? Yeah. So the only thing I was thinking about was, okay, so now you've landed it there. How do you get it out?
Yeah.
Because I remember in David Brin's Earth, Atlantis does an emergency landing in New Zealand, and during the landing, the back breaks. And since there's no structural spares, it's left there on display.
Dang.
Yeah.
Because, yeah, how would you get it out? Huh?
Yeah. So, then of course Beck gets, loses her career, but I don't know what would happen in this situation because it's never happened before.
Yeah. Why would she have been fired? Because,
it could be reckless behavior. It could be, non-standard abort, right? You go through training, so it could be that. Who knows? Yeah, never happened before. The most reckless things astronauts have done are, there's the Apollo 15 postage stamp scandal, which is the crew of Apollo 15 brought up postcards and postage stamps and would sell them. We're planning to sell them after the mission, which you can't do because this is a government mission. You can't do that.
Yeah.
Right? It's that kind of stuff. Which they were all canned. They would never fly again because of that. So.
Okay.
And Scott Carpenter used up too much propellant on his Mercury flight and landed off in the wrong spot, so he never flew again.
Ooh.
So,
okay.
I don't know, though, because she does save the mission, she saves the crew,
Mm-hmm.
but they lose the vehicle. So, I don't know.
Yeah.
I don't know. thankfully, we've never had to ask that question. So thumbs up to NASA.
Yeah.
Zimsky probably has poor OPSEC, though, because at this point, Josh is correlating everything. He talks to Zimsky, who is, well, he's a character.
Played by Stanley Tucci.
Yeah, we love him.
Yes.
He's great. He's great in this.
He's fantastic.
Yeah, but he's... I think they spelled Destiny wrong on this one.
Yeah, because it's supposed to be Destini, right?
I make note of this, don't worry. Yeah, and of course now we have like a aurora here, which we had the real solar flare that came out and did some serious geomagnetic storms, and it looked way better than this.
I never saw it. I slept through it.
Yeah, I had my shin splint, and I couldn't sleep because I was in pain.
I had to sleep because I have to get up at 5 a.m.
Yeah, because you're weird like that. But, a weakening magnetic field would have this because you'd have, the particles coming in and messing with the upper atmosphere. So,
yeah.
So, Josh is then brought in to discuss that the Earth's core has stopped spinning and gives a demonstration where they talk about the wrong things, which we've already discussed.
Yeah.
You would not be worried about the microwave radiation. You're more concerned about skin cancer.
Yeah.
Which would be a problem, and electronics, of course.
Yeah. Remind me, isn't the Earth the only inner planet to have a planetary electromagnetic field?
Yes.
Yeah. Venus is fine. Yeah.
Well, all things...
I mean, the atmosphere hasn't been blasted off.
Yeah, that's mostly due to gravity, though.
Yeah, true, but still, like...
Yeah, it's doing fine. Mercury's okay.
You'd still be kind of fine.
Yeah, and the big problem is the fact that everyone gets skin cancer, and all of electronics would die in solar storms, which would not be fun, don't get me wrong. It'd still be a massive, massive issue, but it wouldn't be this.
It would be annoying compared to this.
Yeah. But we can fix this.
Yeah, even if we came up with some plan to fix the core, we just can't get there. But what if we could?
Exactly.
Right? Those are the lines, yeah.
So again, the accuracy, of course, is magnetic field comes from the fact that the Earth's outer core spins, and it's a iron nickel liquid moving, 1,000 miles an hour.
Yeah. Electromagnetism, one thing. Yeah. Big stuff.
The big things. So the mission is drawn up to use a ship made of Unobtanium, and would use pulsed ultrasonic lasers to drill through the Earth to the outer core and light off some nuclear bombs, because why not? And get the core spinning. I mean, that should be fairly easy, right?
Yeah, of course. That's how it works, right?
So one of the big accuracies is scientists bickering over credit. So in my research, I looked up Project Mohole, which is the Mohorovic discontinuity is the boundary between the crust and the upper mantle.
Okay.
And there was a plan in the 60s as part of the International Geophysical Year to drill to it.
Ooh, okay.
Phase 1 worked so well, the scientists all started fighting each other over it. How awesome it was. And it was discontinued. There's some other issues, I think, but yeah. It's
It worked so well, the scientists started bickering.
Yeah, I was looking up ideas and plans to drill to the center of the Earth, or drill into the Earth. I know the deepest hole, of course, was the Kola Super Deep Borehole, which is 7 miles, about 12 kilometers down. There have been plans to put drill ships in the middle of the ocean, because that's the easiest way. This is where the crust is the thinnest to drill to the mantle. None of those have ever come to fruition. So it'd be interesting.
Probably because you have all the water in the way, right?
It's the water. It's getting the drill rigs. It costs money.
Yeah,
that's the problem. It costs money.
Funding is the greatest threat.
Yeah, but the science advisor for this movie, Doug Stevenson is his name, had a joke, modest proposal for reaching the center of the Earth, which is to use several nuclear bombs to blow open the crust. Okay? And then they would pour molten iron down the hole. And inside that, they would put a spherical probe that could withstand the heat of the molten iron. and it would sink to the bottom of the Earth in about 45 minutes.
That's booking it. Jeez.
Yeah, well, I mean, if you think about it, it's not that dense. It's dense, but it's still kind of liquidish and probably sink down to the very bottom.
Okay.
So it would cost several tens of billions of dollars and would require you to make equipment that could withstand scientific equipment that could withstand molten iron. So
Yeah. I mean, but that's fairly easy.
yeah, exactly. So I did just do some research. Could you use ultrasonics to dig?
Yeah?
Sort of.
Oh.
So this is used in some manufacturing, and it's used in jewelry mostly. You can dig micrometer-sized holes with pulsed ultrasonics and lasers.
Oh, wow.
Yes.
So you can do some drilling,
Yes.
but not like, you know.
Not this.
Not subway tunnel in 30 seconds.
Yeah, not a subway tunnel in 30 seconds. The power requirements for that would be enormous.
Yeah.
So, yeah, no. There is some validity to that idea. It's just not, practical. So let's talk about unobtanium,
Okay.
which that's an accuracy. Someone would give it a name like that.
Really?
It's a scientist nerd thing.
Okay.
It's a joke that came actually out of aerospace development in the 50s. How do you build this stealth aircraft that also can withstand, Mach 5, that can withstand all this? Oh, unobtanium, right? Magic.
Right.
So in the book, it's called Hutterite, and it's a beryllium fluoride crystal with interpenetrating diamond lattices. There's actual scientific paper written about this, and I have it. It's in the description. You can read it.
Cool.
And this is a diagram from it. So this is kind of what the crystal structure of Hutterite would be. The idea is to pack the atoms really close because they'd have, right, the atomic bonds, the electrical bonds between them because it's a ceramic. And the closer you can get them, because the fluorine wants to bond with everything, right?
Mm-hmm.
So make it really, 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 really strong.
Okay.
This is also why, diamond is really strong. It's the strongest material we know because it's got the carbon bonds that are really close together, and it's strong electrical connection.
Interesting.
I'm not a material scientist. Just remember this.
Okay.
I did this over a night. Okay.
Okay, makes sense. Yeah.
So I did some research onto super hard materials,
Mm-hmm.
and so they're unconfirmed to be stronger than diamond, but there are a few that have been theorized to be. So the strength of diamond is about 110 gigapascals hardness, right? It can take a lot of squishing.
Okay.
So the closest one is called heterodiamond, which is a cubic boron carbonitride. It's a boron nitride, right? It's a specific crystal structure of boron nitride.
Mm-hmm.
But no one's actually made it that strong yet. It's gotten close. It's about 75 gigapascals, 75, 80 gigapascals. But the specific cubic boron nitride is theorized to be over 110-ish gigapascals. So it's a bit stronger than diamond. Not strong enough to go to the center of the Earth, though, just to be clear.
Right.
One of the sources I read talks about building nanocrystalline structures that, layered. Basically, you're pushing the atoms in to build a crystal structure made of a titanium nitride overlaid with silicon nitrides that could theoretically be as strong as diamond or even stronger.
Ooh, okay.
So now, here's unobtanium.
Okay.
It's titanium nitride.
Oh.
It's a titanium nitride, like that.
Oh, okay.
The problem is, as you can see, though, the crystal structure is all wrong. As you can see, there's a lot of gaps between the atoms, right? They'd be packed in more deeply. It's also that Paul Pruse's blog, because he actually wrote about the movie back in 2005, because he said, yeah, I know about this. He said it's a boron nitride, so it's in the right ballpark to what a super hard material would be. The problem is there is no material that gets stronger with pressure and temperature. There really isn't. There are some materials that if you cold work them or you put them at temperature, they'll actually perform a bit better structurally, but not to the point where they're melting. I don't know, the core of the Earth.
Yeah, the 9,000 degrees
Yeah.
Fahrenheit or whatever it was.
For this to actually work as the movie describes, so there's something called internal energy, right? There's only so much energy inside an atom inside electrical bonds.
Okay.
Moving unobtainium has infinite internal energy, from what I understand. So it's magic.
Got it. It's made of magic.
There's also a thermal management issue we'll discuss later.
Okay.
But Braz does give one big accuracy. This thing would cost a lot of money to do really quickly.
Yeah, because doesn't the general ask him, like, hey, how much would this cost to make in 3 months? And he says $50 billion.
Yeah. And we could take a check.
Get a card. Yeah, get some miles.
Yeah, you get a lot of miles. And thankfully, unobtainium manufacturing has no snags. It turns out you can actually make it, you know?
Just make it once.
Yeah, thankfully. And then, but, you know, you want to keep this thing a secret, right?
Mm-hmm.
You need a hacker man.
Yeah, you gotta control the internet.
You gotta hack the planet.
Yeah.
So we're introduced to Rat. Look at all this 2000s technology. Look at that computer right there.
Look at all of the CRT monitors.
Oh yeah.
I like that he was like throwing a bunch of the CDs into the microwave.
Oh yeah, that's great. I think we did that once because I wanted to see what that was like.
It's cool.
It was pretty cool. Yeah. And it's DJ Qualls, which he's been in a few things. He's distinctive. Yeah. He's in Breaking Bad.
Yeah.
Um,
He's making the Matrix.
what's he doing?
He's making the Matrix.
Okay.
You know? With CRT monitors.
Okay. Okay. Sorry.
Okay.
So he wants to hack the planet. They want him to hack the planet,
Uh-huh.
as the famous 1996 film Hackers describes.
Yes. Uh-huh.
But
of course.
he does describe a virus that looks for those websites and kills them. That does actually sound like a virus that was developed. There's been a
Really?
few viruses built by like the CIA and different organizations to cripple Iranian nuclear power plants. I've heard of, there's a few of those, but those are like more late 2000s. So I don't know how
early 2000s would work.
Yeah, I'm not a computer person, as you can tell.
Yeah.
With my typewriter, as we're recording this on my typewriter. Get the Walkman out. Where's my phonograph? But one of the big accuracies, of course, is that Rat has reasonable demands.
And they are
Hot Pockets and Xena tapes.
an infinite supply of Hot Pockets.
That's true.
And Xena tapes.
The other thing he does, so he takes out some gum and makes a little noise. I hope this picks it up.
Yeah.
It's called phreaking. It's one of the original hackings that you could do. So up until 2006, AT&T and other phone networks used tone signaling on their phone lines as part of their telecommunications.
Okay.
Right, so you dial a number, right, makes the noise.
Uh-huh.
Famously, AT&T used the 2600 hertz signal on a phone to signal that a phone call had ended. And people would hack into their phone networks and play that to get free long-distance calls.
Oh.
So it says that. So they use that to say that the call had ended, and then they'd use it or something like that. Again, I'm not a computer person. I'm not a hacker.
So basically, it'd be like, oh, it's signal. You tell it that the call has ended, but the call would still be going and wouldn't be charging it.
Yeah, that's probably what it is. Because remember, back in the day, long distance calls actually were a problem. They cost money.
Not with cell phones, where it's like basically the same flat rate.
Or we have the internet, you know.
Again,
I talked to someone from the Philippines over the internet, and
I can have a Skype call with someone in South Korea.
yeah. So it's this is the early hackers discovered this in 1957 because the guy who found it has like tone perfect hearing.
Oh.
Yeah, which means I guess I don't know what that really means, but it means he can hear tones perfectly. I guess he just guessed what it was. It's like, oh yeah, it's an E sharp, I think, or is it C sharp? It was C sharp.
Is that what the programming language is named after?
No.
Oh.
No, of course not.
Dang.
But now they got to build Virgil. They got to build a team.
Gotta get the band together.
Got to get the band together. This is where Iverson and Hicks, back end up on the mission because they actually handled themselves pretty well in a disaster, but not the other guy. He was a mission specialist, so he doesn't get to fly.
Yeah.
No mission specialists on this one.
Nope.
But we see a model of Virgil, which leads to one of the biggest questions we had while watching the movie.
How big is Virgil?
It's very inconsistent. I guess unobtanium is also what the TARDIS is made of from Doctor Who.
Yeah,
Maybe.
it's as big as you need it to be.
Yep. But they start building it. That's pretty cool. Cool montage. Again, good soundtrack.
Yes,
But they're gonna use 6 nuclear weapons?
I think it's five nuclear weapons.
Yeah, because there's 6 compartments. So 5 100 megaton nuclear weapons built by the French to restart the core. So Serge is sitting. He's about this big compared to the nukes, because they end up wrestling them later in the movie. Don't worry.
Yes, these are about fridge-sized.
They're decent sized, and they're 100 megatons. So now here is a mock-up of the Tsar bomb.
They're 200 megatons.
200. Sorry, it's 1,000. Yeah, it's a 1,000 megaton explosion.
Yep.
So this is the Tsar bomb. This is a mock-up of it, and the picture had a guy about. He's smiling. About this big in front of it. Now the Tsar bomb. I think he's a bit smaller. Now the Tsar bomb is about 57 megatons. Sorry, 57 megatons of explosive.
Mm-hmm.
Biggest bomb ever detonated.
Yep.
It is noticeably larger than the French ones.
Yes.
Perhaps the bomb casings are made of unobtanium.
Yeah.
There we go.
Or maybe technology has advanced since since when was the Tsar bomb dropped?
Early 60s. Late 50s, early 60s. I can't remember now.
Okay. Yeah. So it's been like 40-ish years since then. So it's like a lot like computing technology, right? It's gotten a lot smaller. So nuclear technology has probably gotten a lot smaller. Don't look into it.
I don't think so. I don't think so. Yeah. So again, this movie is wrong about this.
The size thing is a bit of an issue.
Also, someone did the math. In order to have a noticeable impact on the core's rotation with a nuclear bomb, you need about 1 million megatons of explosives. So they're about 800 bombs short.
They're 800. Well, I mean, hey, the French can clearly whip these up pretty fast. So
yeah, these bombs that have never been built before.
Yeah. Going on a ship that's never been built before to do something that's never been done before.
Yeah. So this is the part where we discuss navigation, which you did some research on.
Yeah. So they talk a little bit about what the camera technology is supposed to be. Like he says it's like I think they say that it's MRI cameras, or like it's like a CAT scan. Neither of which would work for what they're doing.
Yeah.
Because a CAT scan is just an X-ray, but in 3 dimensions. It's just X-ray going around you. Which for an X-ray, you're shooting X-rays through a person at a backplate that's like measuring the X-ray density, right?
Yeah.
Basically creating a map from that. That's how you can see bones.
Yeah.
So that would not work because you would need to have something. The receiver and the emitter would need to be on opposite sides of the thing that you're looking at. Which when you're going straight down, that would not work.
Yeah.
And MRIs are magic. Originally, they were called nuclear magnetic resonance imaging, but because of the association with those big fancy bombs we just discussed,
That's true.
the nuclear stuff was dropped.
Yeah.
And with that, with MRIs, I mean, the way that MRI technology works is that basically you can imagine the proton essentially is like a bar magnet that spins.
Yeah, except spin up, spin down.
Yeah. So basically, what you do with an MRI is you create a giant magnetic field that goes across the entire person.
Resonance imaging.
Yeah. So you create a giant magnetic field across the entire human body, right? Mm-hmm. Then all of the protons in your body align with that magnetic field, right? And then you emit radio signals that knock the proton off of like 90 degrees from where it was aligned with, but it's still spinning around that big magnetic field.
Oh, okay.
So it's rotating around, but eventually it's processing. The North Pole is processing around the basically big magnetic field lines.
Okay.
And as it's spinning back, well, think about it with electromagnetism is one thing, right? And so basically, as it's spinning, if you have a copper wire or copper wire loop right next to that proton, right? You have the magnetic field changing
you can
next to
generate
it.
signal.
You're generating voltage and you're measuring that voltage, right? And then you're using the time it takes for the proton to get back to process back to alignment with the field, and you're using that to basically measure. That time determines what is made up, what is inside of you, basically. Because
Yeah.
I think it's that like fluids like water and blood take a long time to return back to pointing with the magnetic field, whereas like bone and other stuff like that go back almost immediately. So the problem with that, of course, is that you need a giant magnetic field to align all the protons
They're
and
gonna
then
fix
emit
that.
radium. And then, they're trying. They don't have a giant magnetic field. They're trying to create a giant magnetic field, and you'd only see anything inside of that, right? That's why MRI machines.
Yeah, they're the
like
giant scary donuts.
That's basically just the magnet.
Yeah, have you ever seen video of one of those without the shielding?
I have not. It is scary
It's
looking.
just so scary looking. You just think there's this giant thing is spinning it over and around you.
Yeah.
There's also PET scans, which is positron emissions. Your brain makes antiprotons, and you can measure it.
That's cool.
Yeah,
That is awesome.
That is so cool. That sounds like something out of Star Trek.
Yeah. Measuring the antiprotons emitted from the brain.
Yeah. So I have,
So yeah, none of this stuff would work for looking into rocks.
yeah, I don't know how because we use seismics to do it. Seismic, yeah, because the signals go right because it's the interior of the Earth has different densities and different things going on, so you can measure the change in an earthquake as it goes through. That's actually how we found out oceans under Beijing.
Yeah, and that's also how we found out that there is, different layers to the Earth.
That's also how we found out the Earth's core is spinning a bit slower than the rest of the planet. Because I think it's you bounce it north-south versus east-west, and it changes because, right, it's spinning.
Yeah. I think that's probably how it
It's
works.
also how because the Earth's core is also lumpy.
Yeah,
Yeah. Oops.
that's great.
Yeah.
But also, like, you might want to, like, one of the things that you could do, though, for looking underground is that, the big lasers using ultrasonics, you could probably use the ultrasonics for basically localized seismology. But I think the problem with this is, like, geologists don't use ultrasonics from what I've found. They use it, I think, from what I found, the little bit that I did research with, like, glancing at Google for 10 seconds, is that they use it to like model, like for modeling purposes, for smaller models.
Okay.
I think to represent that, because there's sonics, right, which you could hear, that's 20 hertz to 20,000 hertz.
Yeah.
Then there's ultrasonics, which is 20,000 hertz plus. Then there's infrasonics, which is 0 to 20 hertz.
Yeah.
And most of the seismic activity is measured with
Yeah,
the infrasonic.
Yeah, it's infrasound. That's why. How was it? There's places that are suspected to be haunted. There's just a lot of infrasound around them. Low frequency noise that you can't hear.
Ooh,
but
but
your brain notices it and it
so
freaks it out.
so you're haunted by infrasound.
Yeah, it could be one of those evolutionary things where we had just adapted to know, because like an elephant, right? Big thumpings, or whatever giants were stalking us in the past.
Yeah,
Right.
that makes sense, because humanity came from kind of that area in Africa,
Yeah,
and elephants have infrasound. But also, like, why do you need to see under, like, to quote Ben Affleck from the commentary in Armageddon, how hard is it to drill? You point it down and turn it on.
Yeah,
You're just going down.
yeah. I don't know. Again, I don't know how any of this can. I'm not this kind of engineer.
Yeah.
So it's magic.
Yeah, just go down.
I've also heard X-ray laser, but then again, you need an X-ray source. So I don't know.
But again, you
This
don't need to see.
This is why he has security clearance. We don't want anyone else getting access to this technology.
Yeah, this is the greatest technology invented so far.
Yeah, and Unobtanium has like applications, right? A super hard material. It's great for drilling things, like drill bits. They all have like silicon carbides, drill bits. You can actually go buy them at like hardware stores for like
Nice.
drilling like really hard stuff to drill, like diamond tip stuff. That's why we use them. They're super hard. They don't crack or break. Yeah.
Gonna make a toilet out of unobtanium. That never break.
Yeah, that's true. So then Rome explodes.
From lightning, as it does.
Yeah. The most accurate part is that they were watching football, and then they lose the signal and everyone's mad.
The best part.
That's the most accurate part. Yeah, we're just assume this is wrong. The Colosseum
It's just-
explodes.
How would lightning blow up stone?
Well, you gotta remember, it's really a lot of concentrated energy, superheats air pockets within the stone, and it explode.
Okay, that makes sense.
That makes sense, but like this, again, as the movie describes it, no. The movie
Yeah.
disaster is, again, wrong. So,
Wow.
yeah, instead everyone notices, hey, I have skin cancer now. We all have, what's skin cancer? Mesothelioma? No, that's the other one. Melanoma, it's the other one.
Melanoma, yeah.
Yeah, mesothelioma is the one you get from asbestos. Now, luckily, unobtanium doesn't give you mesothelioma either.
Otherwise, you might be subject to financial compensation.
Yes. But this means they gotta put Virgil in, they gotta fix the Earth.
You gotta put it in the ground now.
Exactly. In the South Pacific, where the Mariana Trench is not. I'll put it this way. It is due east from the Philippines.
And the Philippines is in the northern hemisphere,
Yes,
right?
I've been there.
Yeah.
Where I was in Siargao, if you went east far enough, one, you'd hit the Philippine Trench, which is also very deep. One of the deepest shipwrecks is down there, actually.
Oh, cool.
At 18,000 feet.
Yeah.
Yeah. But then there's Challenger Deep, which is even farther to the... it's like straight... It's in the Mariana Islands, right?
Yeah, yeah.
Which south of Japan. So this isn't where that is. How did they get Virgil there?
Yeah, I was thinking, like, maybe you think they were trying to do a thing where it's like, oh, it's south now because of the magnetic field.
No, I just think they were wrong.
It doesn't have one, so no.
They also spelled integrity wrong on one of the screens, so let's get to it. Okay. So how did they get Virgil there?
Yeah, they built it in Utah.
Yeah. A better launch site would have been in West Texas.
Why West Texas?
Because West Texas has a lot of oil drilling there. The 2 miles under the surface of West Texas is probably the most well-known geology and geology in the world.
Because everyone's mapped it?
And everyone has to map it to look for oil. When I was going to visit you in Arizona, I was going to stop. There's a museum for oil drilling in Midland, Texas, that I know about from the book Core, that I was going to stop at, but the timing didn't work out. Where they talk about this. It'd also be an easier place to hide this mission, right? Oh, it's it's an experimental drilling operation, right? Mm-hmm. This is also where they put it in the book.
No, let's just put it in the Mariana Trench.
I think it's because the Mariana Trench is... Oh, it's the deepest point. Let's put it there. I think it's
closest to the air. That's the same logic of, like, put your rocket launch pad at the top of a mountain.
Here's the problem, though. So you want to get to the Moho, right?
Yep.
Everywhere but there, Moho is really easy to get to. You gotta remember, it's a subduction zone, right? So you have one plate here going in, one plate doing this. Now you'll notice that the crust here, it's going into the mantle. Mm-hmm. It's more crust. You're going into more crust, guys.
Yeah.
So this is cool though. Look at this. This is a good view.
There it is.
Again, this is like one of the 2 parts of the soundtrack that is not in the CD release, which is very disappointing because it's a really good reveal soundtrack.
Yeah.
Which is very unfortunate.
Criminal.
Yeah. You also see kind of early 2000s CGI. If you look closely when you watch the movie, you can kind of...
it kind of looks good with in this shot in particular, because I think they're doing like the whole using the rain to hide the less than idealized CGI.
Yeah, because again, when I was 7, this was the coolest thing I'd ever seen.
Oh yeah.
So they launch Virgil, and I think someone did the math once. At the very beginning, Virgil's moving about 1 mile an hour. Like the first
and it's how far to the center of the Earth?
4,200.
Yeah.
But then they encountered seismic activity, which makes a whirlpool thing.
Underwater tornado.
Yeah. And also they meet whales, which I did look this up. They're about 1,000 feet down, and whales can go up to 2,000. Some of them.
Oh, okay.
So possible. Also, since the ultrasonics are singing to them,
Yeah, that's why they're singing back.
Yeah, so, Yeah, what's this thing? Look at these doofuses. Where are they going?
What's this stupid rock thing?
Why is this rock talking to me?
Why is it giving me NSA plans?
Yeah. Imagine it's the one crazy whale hears them first. God, I'm hearing them. No, you're not.
It's okay there, George.
Yeah, but this also adds some cool intensity, right? You're plunging to the bottom of the Mariana Trench. You got to activate the lasers. It's really cool. It is so cool.
Yeah.
So the other question here before we get to the cool slide is, oh yeah. So how do you talk to Virgil? Because you can't see through the earth.
Yeah, you can't see through the earth. You also can't talk through the earth.
So Stevenson's modest proposal, which would cost several tens of billions of dollars, involves lots of nuclear weapons, would use seismic signals. The probe would wiggle, and they detect it with LIGO.
Oh, yeah, okay, that would make sense.
But LIGO is limited to the kilohertz range.
Dang.
Because anything lower than 100 hertz, the mantle would actually absorb the noise.
Oh, cool.
Yeah, the mantle's not good for that, apparently. It dampens the signal. Again, I am not a geologist. Something involving with the mantle doesn't do that.
So, in short, you can't talk through rocks.
No. You can talk to them, but you can't talk through them.
Dang.
Yeah. But this is a cool shot. Again, the Virgil goes in, the whole... When I saw this when I was 7, it was the coolest thing ever, okay? It still is cool. We watched this 2 weeks ago, and it's still really cool.
It's still awesome, yeah.
This is, yeah. Again, I never noticed, but the green here from the lasers also keeping them melt, right? Because they're trying to...
It's melting around the ship, right? The ship is basically a big long tube going down, and they want to melt around it to kind of keep a melted canopy around it.
Yeah, basically it's called drill mud, actually.
Oh.
Yeah. It's a fluid-ish thing you can use to put your drill in also, because you don't want to bring it all back up, right? Because you want to drill to the center of the earth. You can't bring all the dirt back up from your hole.
Yeah, true.
That would cost a lot of money, and we really, you'd build a mountain.
Real quick. Yeah.
But the hull integrity is good, or the hull integrity.
Integrity.
Yeah.
The integrity is good. I don't know about the integrity, though.
Yeah, I don't know. And that external pressure is about right.
800,000
PSI, yeah.
For PPI?
It's pounds per inch, yeah. That's what they're saying.
Pounds per inch, okay.
At the bottom of the mantle, it's about 20 million PSI. It's going to put a squeeze on you.
Yeah. Dang.
Now, I'll be very clear here. I do look for spelling mistakes in what I do for my job. It's not required, but I always add document quality. This is spelled wrong. So,
spell checking, nice.
Yeah. That gets a lot of love. Yeah,
I imagine.
But this is,
I imagine.
Yeah, this is so cool, though. Again, it was fun watching the movie again because we haven't seen it in years. We did this too.
Look at this early 2000s graphics.
Oh yeah. Oh, this movie's so early 2000s. The hair, style, and again the little synth stuff they add to the soundtrack, which I think detracts from it. You gotta listen. You gotta get the pure one, okay? Unrefined. The full orchestra. Yeah.
All right.
Yeah. So they go from the crust into the mantle.
Which is really cool. Yeah. And it's kind of like, the bottom of ice, like the giant ice sheets.
That's probably what they were going for.
Yeah.
Never thought about that till now.
Yeah.
Look at that. We saw this movie 21 years ago. We're still picking up on things.
Yeah.
Also like how Zimsky behaves. I never picked up on that when I was 7.
Oh yeah, that he's kind of a jerk to everyone.
Yeah, he's the know-it-all. It's like, oh yes, dear boy, keep going.
Yeah, it's like you explain the broad concepts and I'll fill in all of the difficult bits. And he he just motions to him with the pen.
Oh, he's great.
It's like your turn now.
Yeah, or when he's doing his Carl Sagan narration the whole end.
Yeah,
he and Braz bicker over it.
Yeah. I never noticed this, but so there's the 6 of them, right? Where it's Iverson and Beck, Josh and Serge, and then Braz and Zimsky, right?
Yeah.
And they're all arranged in their closest relationships, right?
That's true.
Yeah, I never noticed that before.
Yeah, it's interesting.
Yeah. Anyway.
So as they go into the mantle, they discover a massive inaccuracy, and a massive accuracy. 1, Josh's magical navigation system finds something it doesn't understand.
Mm-hmm.
It's a geode.
Okay.
Here's the problem.
Geodes don't form down there?
No. So, first of all, Virgil plunges into the geode. That's really cool. It falls into this giant geode with all these big amethyst crystals, and then they crash into one.
Mm-hmm.
But when the ship hits everyone goes forward except Josh. He misses his mark and then he curses.
Yeah.
That made it into the final cut of the movie.
Yeah, you could see him mouthing F.
So here's the problem. Geodes do form in cooling magma.
Ooh.
Because there's gas bubbles that get caught in them, right? And the magma cools, it leaves the hole, and all the minerals get stuck in there.
Oh, okay.
They would not form in the mantle, though, like what we see in the movie.
Oh.
They're a byproduct of, the rock coming up. I actually have a geode or two. I got one of those at the meteor crater. It's a cute little guy.
Nice.
Should have put a picture of it in here. And,
Oh, well.
so they go outside, which...
outside into this giant cave crystal.
Yeah, crystal cave made of where the crystals are all amethyst, which again, it's silicon oxide, but some of the silicon is replaced with iron 3+ ions. That's what gives it the purple color.
Oh,
Yeah,
nice.
so like black crystal, right? That's just ionizing radiation hit it and freed up some of the silicon. It's in the crystal structure, so it's kind of in between them. It's free. Free silicon atoms. Yeah, but so they gotta go outside because I guess the lasers can't cut through amethyst.
You can cut through everything else except amethyst.
Yeah, I don't know. Maybe it's a crystal structure. I don't know.
But I think you can kind of see in the movie that it's like reflecting on, like the light's bouncing off.
So
of
maybe
it,
it's that. We never picked up.
But it's ultrasonics, not light.
Yeah, I don't know. I don't know. It's cool though.
Yeah.
So they got to go outside and cut it up. This also brings another question: how big is Virgil?
Yeah, because it looks like it's like twice the size. It's like a double-decker bus size, kind of around.
I don't know. Yeah. So the other thing is, this gas coming out here is liquid nitrogen to cool the inside of the ship. There's not enough liquid nitrogen to make that happen.
Yeah.
So in the book, Hutterite is resistant to a lot of heat. It won't melt, and it's ultra hard. But you know what isn't resistant to heat?
People?
Stuff inside the Hutterite capsules.
Yeah.
So actually in the book, someone is brought on to design like electronics and the components and equipment to take scientific readings deep in the mantle. Like, yeah, it's really interesting. So, yeah.
So also, for reference, this is the front of Virgil.
This is the front of the Virgil, yeah.
This is the pointy bit up front.
Yeah, the laser's right here. All the little laser bits. And the other thing here is in the book also to keep the floaters are called, the drill rigs cool is, so they have, so they have the hole, right?
Mm-hmm.
So they have the drill rig down here.
Okay.
It's making drill mud.
Mm-hmm.
So then suspended above it, they use some of the drill mud to cool it. Then they have trail along giant radiators, basically, and they dump the heat higher up because it's a massive thermal gradient, right?
Yeah.
So they just dump the heat up into the mantle and higher up to cool it down.
Huh.
Yeah, that's how it works in the book. Not here though.
Cool.
They use liquid nitrogen. Maybe it's stored in the Unobtanium. I don't know.
Yeah, there are giant, other parts of Virgil we just don't. There's a giant container for it.
But the big accuracy, of course, is they go outside, turn on their laser to cut the amethyst, and they break the bubble of the geode, and it starts filling with lava. Then the next shot, I did. Oh, the suits also probably wouldn't be built like they are in the movie. They're built like spacesuits.
Mm-hmm.
Whereas in reality, they probably built more like the ones from Sunshine, where it's got
giant turtle ones with tiny,
Yeah, because if you think about it, you're in a high pressure, high heat. Let's put glass in front of your face.
Yeah,
in front of all the heat.
Yeah, that'll work.
That'll be fine.
Glass is notoriously resistant to thermal gradients.
Well, this is unobtainium glass, I guess.
Yeah. Guess.
I don't know.
Also, they're even less built like spacesuits, more built like flight suits.
Yeah, they're kind of built
very
like
thin.
They're built like the spacesuits from Star Trek Enterprise.
Yeah, or like the Mercury astronaut.
Yeah,
spacesuits.
So they cut this. So they start cutting. Also, I think oxygen, because it's an oxygen cutter or something, would polymerize at these temperatures and pressures. Or at least the pressures in the geode.
So it become like plastic.
Yeah, it would be solid.
That's good cutting material.
Yeah, it is. You just hit it.
Yeah.
So it starts flooding with magma. Josh, the brave hero, uses his oxygen tank to help keep cutting.
Yeah, because the thing broke and it ran out of oxygen.
Or something like that. Yeah.
Yeah, I think one of the falling things broke it.
Oh, that makes sense. Yeah.
Yeah.
But Serge decides, I'm going to go outside and help. How long does it take to suit up?
Well, it takes. How long did it take the astronauts on Endeavour to suit up?
Hours.
Hours. Okay.
You have to do
and
pre-breathing exercises, too, to get the nitrogen out of their body.
Yeah. And it takes Serge about
2 minutes.
20 seconds?
2 minutes, maybe? I don't know.
2 minutes-ish? Okay.
Yeah, I don't know.
Very short amount of time.
This is a good shot. So you can see kind of, again, how big is Virgil, right? Because you can see here's Iverson here, and you can see how tall it is. It's actually quite tall here.
Yeah.
And then there's the magma coming down, which is really cool. Really cool VFX.
Yeah.
I really do like the VFX in this. I mean, you can kind of tell that, some of these crystals here are actually real. They're not little amethysts, they don't grow that big. But they're like...
they're physical, they're actually in camera, right?
But the other crystals you'll see are all CGI, and it's like it's filmed in a parking lot.
Yeah.
So
with like light cones for tracking.
Which is really cool. Then, oops. Why is this a different color?
What?
It changes color, doesn't it? No.
It doesn't.
That's my TV doing that.
That's your TV.
So now all of you who have epilepsy now know you have epilepsy.
Good epilepsy test, yeah.
Yeah. So you can see the crystals falling in. It's pretty cool. So they get Virgil to work. The lasers work. Iverson's standing in front of it, and he gets a crystal to the head.
Yeah, it gets domed.
Now, depending on how well that crystal seals up the hole, Ocean Gate. There's a video,
it would just crumple like a can.
Well, there's a video out there of what probably would have happened to you if you were on the Ocean Gate sub, and your body would not even register what happened. That's how fast.
I think I've seen that one where it's like it takes 20 milliseconds for the thing to crumple in, and like for your brain to receive the signal would be 150 milliseconds.
Yeah. So he wouldn't. Yeah, he would. This movie would be a very hard R if it was that accurate. Yeah, but Beck takes control and drives the lasers into the geo, and they keep going.
Yeah, he falls into the lava and I guess just melts.
Yeah, he just goes away.
Yeah.
Can you imagine explaining that to his wife?
Yeah, he took a crystal to the head, crumpled up like Ocean Gate, and then melted away.
Sounds like a drug addiction. I think this is a euphemism for something. He took that crystal.
No, be very literal.
Yeah. Look,
we
we were doing a crystal growth experiment on the shuttle, and he took it way too seriously. Okay, he wanted some samples. Yeah. But then they keep going down. Beck, of course, is now faced with being in command now, finally.
And having to take responsibility and living with the mistakes.
Yeah. So go deeper into the mantle, right? That's a few hours in now.
Mm-hmm.
And they run into diamonds.
Yeah.
A diamond scratches the rear compartment, which forces them to jettison it.
Yeah. And they're all Josh, Braz, and Serge are in the back compartment because that's the weapons control for the nukes,
which are in the compartment ahead of them, thankfully.
Oh, okay, yeah.
Thankfully, yeah.
Thankfully.
So as the compartment starts to fail and crumple, as you see in this picture, Serge realizes, I got to save the timers for the nukes, right? Because it's important to have the nuclear weapons, work.
Properly timed. Yeah, those are the pins for these giant grenades.
Yeah. But Serge gets caught in the compartment and smushed.
Ocean gated.
He gets smushed. Yeah.
Fortunately, it doesn't show anything graphic. I
remember when we saw this. I think Mom, because again I was 7. Mom put her hand in front of my eyes for the scene. Here's the thing, though. The deepest diamonds form at about 500 miles down at deepest. They're called ringwoodite.
Whoa.
Yes. Now, this is mostly on a molecular level, though. You got to remember, at these depths, it's like a soup of different minerals at high temperatures and pressures. So they're kind of like a syrup kind of liquid.
A soup.
Yeah. Now, what's interesting about ringwoodite, actually, is we actually can get samples of it from Mid-Atlantic Ridge and different places, right? We have actual access to mantle minerals because, it comes up.
It gets kicked up because of plate tectonics. Yeah.
We found water at a molecular level in ringwoodite.
Really?
Yeah, it's called subterranean oceans. If you read Stephen Baxter's Flood, it's the only book that talks about this. But the flood's caused by those subterranean oceans coming to the surface.
Wow.
Yeah. Yeah, so there's
that's awesome
actual water deep in the mantle, like in the upper mantle.
Dang.
Yeah, so that's pretty cool. We also found it with seismic waves, because again, there's the one under Beijing, the size of the Arctic Ocean, about 400 miles down.
Wow.
Yeah, it's really cool.
Yeah.
Of course, thank goodness that the compartment that gets lost is the one in the back.
Yeah. Can you imagine if it was like the second compartment?
Yeah. Uh-oh. That's not good. The other thing here is diamond shouldn't be able to puncture unobtanium, because unobtanium is harder, which means it's stronger than diamond.
Yeah.
It's a super hard material. So I don't know.
But it wouldn't be dramatic to have Serge get ocean gated.
That's true. So I don't know. But Braz is trying to get to open the door from the compartment to save Serge, and you can see that there's breadboard circuitry in there, which is not what you have in an operational system. So that's accurate. It's a crash program made in 3 months.
Yeah. Built real fast.
Yeah. So of course Serge gets stuck in the compartment, is smushed, and they jettison it, and it kind of crumples up. We don't know mechanical properties of unobtainium, of course, so we don't know how quickly it would get,
Crumpled. Yeah.
So debatable.
Yeah. You can see the weird kind of design of that compartment though.
Yeah.
It's funky shaped.
Oh, it's being smushed right here.
Yeah, but also, I mean, like in general, the shape of each of the compartments is still kind of funky.
Yeah. Well, it looks cool though.
Yeah.
Again, it's the coolest thing I've ever seen. 7.
It is really cool.
It's a good, it's a good VFX film.
Mm-hmm.
And then they make it. Of course, Josh has an emotional moment with Beck because Serge, of course, is his best friend, and
yeah, he's like, I was 2 inches from him. I told you to put the door up, and you didn't.
And of course, Beck has to, accept responsibility for once.
Yeah.
Making the decision that is not the popular but right.
Mm-hmm.
And they reach the outer core. Ooh,
it's brighter.
yeah.
Ooh.
Yeah, which again, good on the VFX team to make it them distinct.
Yeah.
But here's an interesting fact. They would be experiencing 1.1 to 1.2 G at the core mantle boundary.
Really?
So here's a diagram. Here's the density, right? Here's the core.
Mm-hmm.
And there's the mantle, right? You can see the boundary.
Uh-huh.
Here's surface gravity. So 1G is about there. So somewhere around the core mantle boundary, you would actually be heavier because the core is a dense ball of iron nickel the size of Mars. Mercury has the same surface gravity of Mars, despite the fact that it's smaller. Why?
Because it has a giant iron core.
Because it's a giant ball of iron.
Yeah.
So that's an inaccuracy there, guys. So,
yeah.
Yeah.
But also the angle at which they're standing inside of Virgil is
It's
constantly changing, so...
Yeah, that's, again, how big is Virgil? How do they get around in it?
Yeah, because they're going straight down, but it's also diagrammed to being a 45-degree angle, but they're walking on it as if it's flat. Like, it doesn't make any sense.
I don't know. But as they reach the outer core, of course, they would discover a few things. Most importantly, that the density is wrong. They're wrong.
Oh, yeah, because the outer core is less dense than they had predicted, and so the giant nuclear explosion waves would just bleed away into nothing.
They'd fizzle out. It wouldn't work. Which, that's accurate, right? The place we've never been turns out to be not like what we expected.
Yeah,
Make note
never
of this.
happened before.
But the other thing that happens is a microwave laser breaches the magnetic field and roasts San Francisco.
Finally.
Yeah, that's good for the housing policy over there.
Mm-hmm. Destroy it all.
Okay, then. So this leads to the activation of destiny. So let's get some of the notes here first. So the other question I had, though, was as I was writing the slides, was what kind of simulations were you running that you didn't account for the density difference? You know what I mean?
Yeah. I mean, to be fair, they only had 3 months, and computers were expensive back then.
That's
so
pretty true. Yeah, Rat had all of them.
Yeah.
One of the grad students was using the T1 line to watch Sailor Moon crap. So,
Yeah.
I'm quoting the movie here. Don't get mad at me. I don't know what Sailor Moon is.
Yeah, it's the movie's opinion, not ours.
Yes. Also, the smelly linear differential equations. That is absolutely true. All the kids who like that are all smelly. I don't know how different the density is that the bombs wouldn't work.
probably pretty
know.
big discrepancy.
I don't know. So the whole San Francisco thing, of course, whatever. We assume that's wrong. So now the big thing here is Destiny, the big laser that they fire into the Earth that caused the core to stop.
To begin with, yeah, that's what set this whole thing off. Is the hubris of Zimski.
Yes,
which it's a big hubris.
Yeah, that's understandable.
Yeah,
I don't know how that works. I'm assuming it doesn't. I'm assuming it's silly.
Yeah, because like I think he kind of describes it as like a giant electromagnetic pulse.
Yeah, so they can generate earthquakes from deep fault lines. Mad.
Yeah, mutually assured destruction. But like, how? Why?
I don't.
How?
Again, the book makes more sense. They use a Hutterite drill to put nuclear bombs under deep fault lines.
Yeah.
So
not electrical shock.
Yeah, I don't know. And the movie spells Destiny wrong the entire time. It's Deep Earth Seismic Initiative. Destiny. Not Destiny as in Des Tiny.
Destiny.
Yeah.
Destiny. There's an I at the end, not a Y.
Even like the soundtrack and the title cards get it wrong. Also, they use America's power grid because the San Francisco thing prevents the power grid from working to feed Destiny. The problem is, of course, Alaska's power grid is
from Canada.
Yes. So that's very interesting. Yeah. Also, the thing I made note of, it's a 2003 plot point, right? It's mutually assured destruction, building weapons of mass destruction. This is 2003, right? Mm-hmm. November 2001, the United States invades Afghanistan because of...
For some reason.
No, that one actually made sense because we're looking for Osama bin Laden. He was there and the Taliban wouldn't give him up. That's why we invaded. In 2003, we invade Iraq. That one's more debatable. That one's questionable. So it's a very early 2000s kind of plot point about weapons and weapons of mass destruction and paranoia, post Cold War paranoia, that kind of thing.
Yeah.
We're not getting out here to endorse any views, just so we're clear.
Yeah.
So let's see. Yes, this won't work. Also, the CGI in this part is probably the worst in the movie. This looks like Attack of the Clones.
Yeah, I think I made this comment while we were watching it, but this is it looks a lot. It looks like it was from the Incredibles.
Yeah, I can see that too, because it's got a giant spark plug.
Mm-hmm. Going into, I guess that's a coil.
A copper coil deep into the earth. I don't know.
Yeah,
magic.
It doesn't make any sense.
But Rat and Josh decide to start hacking.
Yeah.
The problem,
hacking the Earth.
The thing is, they want to send a message to each other, and they use prime numbers to create a title image that can do different encoding. The problem is, one isn't a prime number.
And they use that's the first number they type in.
Thank God both of them don't know that.
Yeah.
This also results in what's called Plan C. Restart the core somehow.
Yeah, so they discover that the plan A is to go down there and drop the nukes, which isn't going to work because the outer core isn't dense enough. Yep. Plan B is to fire Destiny, which they don't want to because number one, they keep spelling it wrong, and number two, it caused the problem in the first place, so it'd probably just make it worse.
Yeah, it'd cause a core instability, and
it would end very, very, very badly.
We would all die.
So they go for Plan C.
Yeah, which is they hotwire the nukes to detonate at a specific time. They drop like stones in a pond, right? Mm-hmm. Multiple explosions. Well,
I mean, first Zimski freaks out about this because he built Destiny, so he wants to just go home and fire it.
Yeah.
And so he freaks out. I was like, Plan C? Restart the core somehow?
I have quoted that line so many times in different ways.
His freak out is fantastic.
It's great.
I think there are clips of it on YouTube.
You can check it out. You can find it.
Yeah.
Yeah.
But eventually Zimski's the one who does figure out that to do...
Because he's a brilliant genius guy. He's just a jerk about it.
Yeah.
So the Plan C requires bombs to be detonated in sequence to the millisecond, placed within a fraction of an inch. Does this account for the fact that the compartments would drift?
No.
Yeah. So now they hit the core of the Earth. Oh, it's 2,600 miles. Oops.
Yeah, you're not going all the way to the center. Earth is, what, 8,000 miles across?
Yeah, so it's more like, that makes sense.
Yeah.
Well, here's the problem, though. Also, they're hot-wiring nukes. That was my question. How easy is it really to hot-wire these nukes?
It's very simple. You got to cut the red wire. I mean, no, cut the blue wire.
Yeah. Because I remember, Armageddon showed us, all you got to do is hit it with a wrench.
Oh, yeah.
Right? And have really good editing to hide the fact that your 30 seconds became like 5 minutes.
Yeah. Got to give an impassioned speech. That slows down
that's
time.
true, yeah. There's no impassioned speeches here.
Yeah.
So the problem is, for Virgil to jettison compartments, they have to be compromised.
Well, yeah, so the nukes themselves won't be able to go out in their little pods because they just melt.
Yeah, the Unobtanium isn't strong enough in this spot. I guess that it's too thin or something.
Yeah, so they have to put them each in one of the different compartments of Virgil and then jettison them each individually.
The problem is, you can't jettison them for no reason.
Yeah.
Which
they have to be compromised.
But there is a hydraulic key ring that holds them all together. The problem is the only way to access the release is to go into the crawl space, which is full of core fluid at 9,000 degrees.
Yeah, which would melt. It's going to melt anyone who goes in there.
Another quote I use a lot, which is Zimsky saying, "Well, what's it doing there?"
Yeah.
Which
he gives the right answer, right? Is that he built it in 3 months.
Yeah, there's an obvious design flaw that didn't get caught because it's a crash program.
Yeah.
He also didn't think he'd be sabotaging his ship intentionally.
Yeah.
So that's accuracy right there.
Yeah.
So then Braz goes into the core, into the impeller bay. He draws the short straw, of course. It's his ship, his blood.
Mm-hmm. Well, he tries to draw the short straw, but they're all the same length.
Yeah, he's cheating.
For some reason.
He's cheating. He wants to die. He wants to sacrifice himself for the ship.
Yeah.
So, also being stuck in that ship with Zimsky. Oh my god.
Yeah. He describes it as a floating septic tank, which I would agree with if I was stuck with him.
Yeah. It's not a stupid ship. Okay, it's not a stupid ship.
It's not a stupid ship.
So Braz goes in. He's holding the hydraulic key. I never picked up on that earlier. At first I thought it was an axe, but it wasn't. No, it's the key to go in. And it melts because it's core fluid at 9,000 degrees Fahrenheit. The suit can't take it. Mm-hmm. Which would be an accuracy, right? The ship could be made of thicker material, but the suits might not be. So they might, to be mobile or whatever. So they might actually be able to take as much temperature and would fail. Mm-hmm. So that's an accuracy there. Here's the thing, though. Would there be slag, or at least some stuff in the crawl space?
Yeah, but that would cost money to put in there.
That'd be really hard for.
And
VFX.
It's 2003 CGI, which it still looks good, but I don't think it'd be that great.
Sparingly. Also, when Braz opens the door, right? Because the door he opens up, there's all these plastic buttons. They're just exposed. Yeah. You'd see them go.
Yeah, they would melt with a typical standard fire, and they would definitely melt with.
But it's a really well done scene, and the soundtrack for it is still really good too.
Yeah.
So Braz, of course, goes to the crawl space. He reaches in. His suit's failing. It's starting to melt, and he turns the thing, and
it turns this key ring thing.
Yeah.
With his hand.
And he unlocks it, and Virgil continues on, while Rat hacks the planet.
Yeah. Also, he dies.
And Braz doesn't make it because he's in the impeller area. He's not coming back.
Yeah. He dies and melts. Sucks.
So Destiny, of course, is about to fire, but it doesn't, because Rat redirects all the power and somehow builds all these power lines to redirect the power to Coney Island.
Mm-hmm. He constructs a new grid by hacking the internet.
He types in, I'm in.
Yeah.
Right? So Josh and Zimsky begin deploying the nukes. Mm-hmm. And as they're deploying them, they discover a flaw. Zimsky doesn't account for MRI bias from the cameras because the magic cameras have a bias. I don't know how it works. The magic cameras have a different scaling factor, magnification factor that you have to account for in your calculations.
And Zimsky didn't because he didn't know about that.
Yeah, because he wasn't there talking to Beck and Josh in the beginning of the movie.
Yeah, when Josh is explaining how it should technically work, even though it doesn't at all whatsoever.
So then they gotta go back. They gotta fix the right. They're missing 20 or 30 pounds of plutonium.
6 or 7 pounds.
Whatever, 6 or 7 pounds of plutonium.
Mm-hmm.
And of course, and Virgil gets hit by a flare. One of the flares from the core.
From the core. I don't know how does the core flare?
I don't know. We've never been there.
Yeah,
don't ask me.
But how would it flare? Okay. Yeah.
Well, actually, so the core isn't entirely iron nickel. I read this because if it was, the gravity of the Earth would be a lot higher. So it's actually
really?
Yeah, I remember reading once a while back. So you can find like the atmospheric composition of Earth and with the rock composition, like roughly what it should be based on the solar system. There's a lot of xenon that's missing, and it's theorized that all the xenon is stuck in the core.
Xenon is pretty dense, so that would make sense.
Yeah, so it's like there's an iron crystal structure, and the xenon's caught in the middle of it.
Ooh, okay.
Yeah, but
it's interesting.
Here's the thing, though. They're shouting as this is going on.
Mm-hmm.
So, right, Beck is driving the ship here.
Mm-hmm.
Zimsky and Josh are back here, and they're shouting.
Yeah.
Beck says, "Come on, guys, I can't hear you."
Yeah, even though they're somewhere between 30 and 600 feet.
Yeah.
Because we don't know the size. It can somehow hold an infinite supply of liquid nitrogen.
Again, as I said, as I typed this in all caps, Virgil isn't that big. You can hear them, Beck.
Yeah.
So they wrestle the nuke, which Aaron Eckhart has said that's one of the things he talks about. It's like, this movie, I wrestle a nuke in this. It's not, to make fun of it. Then Zimsky gets stuck. It rolls over his leg. He gets stuck in the compartment when Beck ejects it.
Yeah.
But before this happens, Zimsky does say, "You can enhance the bomb," because Virgil is powered by a nuclear reactor.
Yeah, so you can just all you need to do is take out the core, right? And then put it right next to the last nuke, and that'll give you the 6 or 7 pounds of plutonium you need to blow up and restart the Earth.
Okay. I do not know what was in Zimsky's cigarettes, but that would not work.
Yeah.
Reactor grade plutonium, uranium, isn't explosive versus weapons grade uranium. That's why it's called weapons grade.
Yeah.
So I don't know. Also, these are probably fusion bombs at this point because Tsar bomb was a fusion bomb. So I don't know how this would help.
Yeah.
The other question we have is, where is this?
Yeah. Presumably this is somewhere under the main bridge top compartment.
So Beck's like right here, right?
Yeah.
Of course she's still going, "Come on, guys, I can't hear you." He's right under you.
Yeah. They're having communication problems, even though they're at most 5 feet apart.
I don't know where this is, but it's really cool. I mean, that's a really cool setup, and
it does look awesome.
It is really cool. Set design's really good in this movie.
It's phenomenal.
Yeah, and of course Josh has to pull it out with his hands because the chain melts.
You see the little part in the middle of the giant ring with like the 2 handlebars? That's what he's got to pull out.
Yeah, and then he carries it up and puts it next to the bomb, and so there is an eject button.
Yeah, there is an emergency eject button. So he did factor in the possibility that he'd have to eject.
Yeah, I don't know what's going on. Maybe it was just for this compartment. I don't know.
Yeah, I don't know.
Yeah, so this leaves, of course, Virgil stuck without power at the center of the Earth.
And then these nukes are about to go off.
Yeah. They get hit by a massive shock wave that's going to, again, restart the core of the Earth. You're probably not going to make it.
Yeah.
But look at this VFX, though.
Oh, yeah.
It's really cool. Again, this is the coolest thing I've ever seen when I was 7.
Yeah. But also, again, look at the unique design of Virgil.
It's really cool looking. You got the impellers, too. That's really neat.
Yeah. Looks awesome.
Aha. As the bombs begin detonating.
Mm-hmm.
And, the core... And, of course, somehow the people at the mission control recognize this very quickly. I don't know how.
Yes.
Also, the magnetic field's restored instantly by this. No,
yeah.
I don't think so. I press X to doubt.
It would probably take some time, right?
Yeah. So, but of course, Josh remembers that unobtanium is magical. Right?
It has infinite internal energy.
Yeah. So what they do is they take the power lines from the reactor and weld them to the unobtanium. And of course, as you can see here, here's unobtanium at really high temperatures, right? Because it can resist heat, but it's still going to dump some in. Here's Beck roasting her hand.
Yeah, on it.
So that's
Yeah, put your hand on the middle of the oven.
yeah, that's good. That's a smart thing. I have a scar on my ring finger, my right hand, that was made because I bumped the pizza stone when I was making frozen pizza once, and that was about 400 degrees. So
Yeah, and this is 9,000-ish.
this is the core of the Earth.
Yeah.
The other thing here is they say we can start the impeller, but not the laser. You need the melt to go through. The mantle isn't the mantle and the core aren't water or liquid like that. They're still soup. They're rock. They're melted rock.
You would very much need the lasers.
You'd still need it. Also, the lasers, on the sides and the impeller parts also keep the melt going. So,
Yeah.
I don't know. And of course, they go up through. It's really cool though because they're running the nuclear explosion. It's really good. Again, soundtrack for this is really good. It's called "Interred Servants." That's what it's called in the soundtrack. You can find it on YouTube.
But look at this. Look at this beautiful, beautiful CGI. Look at this.
Again, the VFX team did a really good job with this, trying to visualize the inside of the Earth.
Yeah, because you could just see the inner core, and they're in the outer core, and there's the nuke going off behind them.
And of course, Zimsky has a good at the very end. He's still doing his, Sagan.
Carl Sagan.
And he's like, he stops. What am I doing?
Yeah, because he has a physical recording device. Yeah. He's about to get nuked
at the center of the Earth.
Yeah, there's no way anyone's gonna pick it up.
Yeah, you're not finding that.
Yeah.
But of course, the impeller starts, they outrun the nuclear explosion, and it's really cool.
Yeah, they're going back up.
Yeah, up through the mantle, through between the diamonds, really fast, even though they really wouldn't.
Yeah, the density of the Earth is still
it's like
high.
It's about 4 times that of water in some parts.
Yeah.
And then they keep going up, and they find themselves between tectonic plates near Hawaii.
The middle of the Pacific Plate.
Yes. The Mariana Trench is between tectonic plates.
Yeah.
Hawaii is a hot spot. Good place to leave, though.
Yeah, because it's thin there.
Yeah, it's thin.
Would have been a nice place to, I don't know, maybe start.
Oh, yeah, launch. But then how'd you get the Virgil going in though?
What do you
mean?
How
you mount the launch mount for all of this? Again, West Texas would have been a better spot.
Yeah, I mean anywhere would have been a better spot.
Yeah, just not the part, or a mountain range would be worse actually, because that's great because it's thicker.
Yeah, but I mean, there are lots of other better spots. Pick one of the worst spots.
Yeah, but the Earth is healing, of course, really quickly. And they end up going up, and of course the problem is that, the mantle is nice and toasty, and unobtanium is magic. Magically converts heat to energy. But, at the bottom of the ocean, it's pretty cold.
It's a magic thermocouple.
Yeah. So that's, ends up there, and they lose contact with them, which, again, they wouldn't have contact with them in the first place. And they're stuck underwater, 800 feet down, with something with the solar signature of a rock.
Yeah. And it's cold as ice.
Yeah, it's cold as the bottom of the ocean is.
Yeah, which is nowhere near 9,000 degrees Fahrenheit.
Yeah.
It's like,
but
they
find it. Of course, it's an optimistic film because
the ultrasound,
the ultrasonics.
Yeah, they're singing to the whales at the beginning, and they use the whales to find them. Rat figures it out.
Yeah, of course, it's the wrong ones. The ones in the beginning are humpback or blue or something. The ones at the end are orcas.
Oops.
So maybe the orcas were trying to here they are, here's the food. Because the orcas have been attacking boats now. So
yeah, maybe it could have been trying to eat them.
Yeah, but hey, the crew is rescued. Josh and Beck make it. It's a happy ending. The Earth's been saved. Though the other thing I forgot to note here, they're on. I don't know what the ship was. It's not is it the Enterprise aircraft carrier?
I think it is. I don't remember.
Or the USS Ranger, I think it might have been. And General salutes the admiral in charge of the ship. That's not how that works.
That sounds like the chain of command if I've ever heard it.
I don't think... No, the chain of command was what Josh was wearing around him that melted when he was trying to get the reactor core out.
Yeah.
It's gone. It's at the bottom of the Earth now.
Yeah.
But it's rescued. The day is saved. Problem is, though, its mission's secret.
Super secret mission.
Except Rat knows.
Oh my gosh.
And he goes... Oh, man. He goes to a cyber cafe and hacks everyone's computers and unleashes all the information.
Leaks it all.
This screenshot is so 2003.
Oh my gosh.
He's going to a cyber just the haircuts. Oh,
the clothes.
Oh, everything is I remember 2003. I was 7, but I remember it. I remember the fashions of the time. Oh man.
Yeah.
Oh man.
The early 2000s were a lawless time.
Yeah, they were. But the day is saved. Destiny gets out, and that's
Rat says, "World meet destiny. Destiny meet world."
And then we zoom out on the Earth spinning the wrong way.
Spinning from east to west instead of west to east.
And that was the core.
The core.
Not the most space movie we'll be covering. Obviously, it's got the shuttle landing sequence, which is probably what our focus was, which we didn't really talk much about. It's like, this won't happen, probably.
Yeah.
So it's got cross-range capability. They could do it. It'll be fine.
We came up with like 4 or 5 different emergency abort scenarios, so and we're not in NASA.
Yeah, so it's dubious, but it makes for a cool scene and sequence. People unfairly target this movie a lot because this movie was pitched as Armageddon but down, which probably leads to some of these beliefs about it.
This is a way more, in my opinion, it's a way more competent movie than Armageddon.
Yeah,
Armageddon is a 2.5 hour long trailer for Armageddon. The Core is an actual movie.
Yeah, The Core, again, I think that's the part that probably baffle people if they were to watch it, which I do recommend watch it. The soundtrack's great.
It's a great movie. The characters are super well developed.
Yeah.
Right. They have a fantastic cast.
Yeah.
Right.
Oscar winner Hilary Swank, just coming off $1 Million Baby.
Yeah, it has Aaron Eckhart, who played Two-Face
Harvey
Dent, Two-Face in The Dark Knight.
Yeah.
You had
Stanley Tucci, of course.
Stanley Tucci, of course. Yeah.
Yeah, Delroy Lindo hasn't gotten much, unfortunately, as an actor.
But I mean, like, again, all of these characters are just fantastic.
Yeah, it's really well written.
It's very fun to watch. I highly recommend watching it.
Yeah.
Love this movie.
Yeah, we actually really like this movie, and we're not joking. This isn't like sarcasm. I actually do really like this movie.
This is a great. I like this movie. This is a great movie. Watch this movie.
The science is wrong. It's kind of silly at parts. Again, you're wrestling a nuke, but it is. Yeah. I think that probably shocked people. It is competently written though. So I give it a lot of credit for that. And again, for me as an individual, as an engineer, this is the movie that got me interested really in science and engineering. I can say that, could you actually do this? No, but it's a fun thought.
Yeah,
it's good. Yeah, and of course the soundtrack here at the end is Echelon by 30 Seconds to Mars. I found that out like a year or two ago. Cool. I was curious, like, what's the soundtrack at the end of this? Because I liked it.
We talk a lot about the soundtrack. It's a great soundtrack.
It is. I like it. I really do. So let's wrap this up. So the next movie special for Christmas. Oh, this is the 4th of July special, by the way. Happy
4th of July, everyone.
We should have done Armageddon for the 4th of July. That movie's so patriotic.
Yeah, that would have made more sense. Whatever.
Whatever. So the next movie for Christmas is going to be Deep Impact. We're going to see how accurate that is. And you look at this screenshot of the spaceship in that one, and you can see already we're going to have 5 slides dedicated to it at least.
Oh, yeah.
Yeah.
Oh, yeah.
So, yep, that's Deep Impact. That one didn't have as deep an impact on me as the Core. But, hey.
Yeah.
I also own the novelization of the movie, by the way. I found it like a used bookstore for free, basically. I was like, I'll just take this.
Yoink.
Yeah. So, yeah, that's the Core. This is end of mission. You have any final thoughts?
Not really. Just watch the Core, enjoy it, give it a fair shakedown. Don't think too hard, I guess.
Don't take us for granted.
I'm leaving now. Bye. This has been an end of mission.